Welcome back to Intellify. I'm Rasika Ramakrishna and let's continue the chapter on applications of trigonometry. Exercise 9.1 question number 13. As observed from the top of a 75 meters high lighthouse from the sea level, the angles of depression of two ships are 30 degrees and 45 degrees. If one ship is exactly behind the other on the same side of the lighthouse, find the distance between the two ships. Alright, so here is your sea. You have two ships here and you have a lighthouse here. Observing these ships from the top of the lighthouse, right? So obviously there is going to be an angle of depression. So we are given the angles of depression of both these ships from the same point, and we are also given that one ship is behind the other, and we are asked to find the distance between the two ships. Alright, so now that we have a kind of some idea as to how the situation would look, let's try and draw the figure. Alright, so here is the figure for the question. So here AB is your lighthouse and it's 75 meters in length. Alright, and we have a ship at C and at D. Alright, and we are observing these ships from the point A. So the angle of depression when you're observing the ship at C from point A is 45 degrees. So alright, so whenever you're talking about angle of elevation or angle of depression, you should always have a line of sight. In most cases, when we're talking about angle of elevation, the line of sight happens to coincide with the ground level. Therefore, we don't draw the line of sight explicitly. But when we're talking about angle of depression, we have to explicitly draw the line of sight for it to make sense for us. Therefore, let's draw the line of sight from A, or you could call it through A. So we draw a line parallel to the base or ground. So AE is going to be the line of sight. So now that we know that the angle of depression of the ship at C as observed from A is 45 degrees, we can say that angle EAC is 45 degrees. Alright, so now when we are observing the ship at D, from the point A, we have an angle of depression to be 30 degrees, which implies that angle EAD is going to be equal to 30 degrees. Alright, so now notice that there are two triangles in this figure and we only have the two angles in here. I mean, this figure is completed, but when you draw it along following my instructions, you will have only these two angles. So how do we find the angles in the triangle? Well, we make use of the properties of parallel lines. So we have drawn the line of sight parallel to the ground. Therefore, we have two parallel lines here, and angle EAD and ADC are going to be alternate interior angles, and angle EAC and ACB are going to be alternating interior angles as well. Therefore, by properties of parallel angles, which are alternate interior angles in this case, we have angle BCA to be 45 degrees and angle CDA to be 30 degrees. Alright, so now with this information, let's go ahead and tackle the question. What do we have to find? We have to find the length of DC. Alright, that is the distance between the two ships. So now we are given AB. So notice that AB is also the common side to both the triangles that are given to us, or both the triangles that we have constructed, right? And AB is given to us, which implies that we can use this AB and the angles in here to find some other side in the triangle. So let's see how we go about that. So first we find BC, right? So we try to find BC using AB. So what is the trigonometric ratio involving the opposite and adjacent side? Well, it's tangent theta. So let's look at triangle ABC. We have tan 45 to be equal to AB by BC, which is opposite by adjacent. 1 is equal to 75 by BC, which implies BC is equal to 75 meters. So using AB, we have computed BC to be 75 meters. Alright, so now we go ahead and find BD. We can do this because AB is present in triangle ABD as well. So again, what is the trigonometric ratio involving the opposite and adjacent side? It is tangent theta. So tan 30 is equal to AB by BD, which is opposite by adjacent. Therefore, 1 by root 3 is equal to 75 by BD, which implies BD is equal to 75 root 3. Alright. So this is the length of BD. So now we have to find CD. That is what the question has asked us to find. So BD is equal to DC plus CD, and we know the values of BD and BC. Therefore, CD is going to be nothing but BD minus BC. So BD here is 75 root 3 and BC we just saw was 75. Therefore, we have CD to be 75 times root 3 minus 1. Therefore, the distance between the two ships, which is CD, is 75 times root 3 minus 1 meters.